Okay, so we are going to discuss this one. What is the output of the following Java code? Okay, so it is basically we have a recursive function here, right? It takes in an integer, so there's a base class like this, so base case like this, right? When n is less than or equal to 1, it returns 1. So that's the base case, and then after the base case there's this recursive function again, right? So this func call is called again here, right? So let's execute this guy, func5. Okay, all right, so here instead of n we are passing in 5 less than or equal to 1 is false, so it will not print that. It will come here and it will again call func n minus 3 plus n, right? So this will call again result is equal to func n minus 3 means that is n is 5, now 5 minus 3 is 2, plus n means 5, right? So here again it's a recursive call, so we need to solve this, right? So how do you solve that? Again execute the func with 2. Okay, so I'm going to execute func with 2 now. 2 less than or equal to 1 is false, so it will not go there, it will come here, and then it will call func n minus, so here again result is equal to func n minus 3. So n is 2, so 2 minus 3, which is negative 1 plus n, which is 2, right? So here we need to evaluate this. So the value is 1 here, so 1 plus 2 is 3, so here the result is 3, and 3 plus 5 is 8, so the result is 8. So for func 5 the result should be 8, right? So that's the answer. Okay, so the question number 2. Consider the following program written in Java. The program illustrated below is implemented to solve the famous Tower of Hanoi problem. So that's a Tower of Hanoi problem, right? So there are basically you have 3 towers, and one tower will have some disks. You'll need to move the disk into another tower as is, like the keeping the tower intact, right? Say for example, if we had 3 poles like this, right, and let's say we have 3 rings, right? So end of solving this, so these 3 rings should go end up here. So this is the from tower and this is the to tower, right? So the rules are, you can take one ring at a time and place it in another pole, but at any point the ring that is coming up should be smaller than the ring that is below, right? So this configuration is correct, but if we have something like this, like here we have a smaller one, you can't put a big one up top, right? So this is wrong. All right, so that is the tower of Hanoi problem. So basically you are moving your rings from one to rings or discs from one to the other without changing the form, right? Preserving the form as it is. All right, so note the blanks indicated A, B and C, right? A, B and C. Okay, so this is a pretty simple question if you have studied this issue, this problem, right? So here we are taking some arguments. Args.length not equal to -1, so not equal to 1. So basically it is taking an argument probably from 1 up to 9, so single digit. So it says if the argument's length is not equal to 1, that means it is more than 1 character. So there's an error, right? A single integer argument needed. So that is what it means. And if it is the case, then the system exits. If the argument is fine, say for example I am calling this Hanoi, okay, Hanoi .exe, we are calling the executable with one argument, say for example 3. So that means there are 3 disks here. Okay, all right, so here we are creating an integer n value with arg0. So whatever we pass in, so if it was 3, then 3 would come here, right? And n will have the value 3. And then this Hanoi h underscore do Hanoi function is called with that 3 value, so 3 disks, and here is the from pole and here is the to pole, right? And what you have here is the intermediate one. So from the 3 poles we have one, the from pole is where the disks originate from, and to pole is where the disk will land at the end, right? So this guy is the U, which is auxiliary. Okay, so in the logic basically you are passing in the number of disks. So this number of disks should be greater than 0, right? So this is basically this should be an if condition, if n is greater than 0, right? So that is that. And then for the B, it is the first half. So it's basically moving from to the auxiliary. So this is from F to U normally. So what we can see here is so it should be either this guy or this guy. So you can say, yeah, so you should be using this for the second argument, C, right? And so this should be B. So it's already given, right? So this is B and this is C. H underscore do Hanoi n minus 1 U F T, and then this is H underscore do Hanoi n minus 1 T U F. right? Okay, so probably so that should be the answers, and we'll move on to the third question. Okay, so the third question, what is the output of the following Java code? Right, so we have a recursion here again. So function is called, and again similar to the previous one, there's another function here. But here it's calling function 7, right? So it's a different argument here. All right, so again we are going to start the call with func7, right? So this 7 is here, so there's 7 less than or equal to 1 is false, so it will come here. Again there's a recursive call here, right? So from here the result is equal to func n minus 3, that is 7 minus 3, which is 4, right, into n, which is 7, right? Now we are moving into another call of the recursive function. So func4, so instead of 7 now it's 4, right? So 4 less than or equal to 1 is false, right? And it will come here, right? And then that will be called. So basically again the result is equal to func n minus 3 is 4 minus 3, which is 1, into n, which is 4, right? And now we need to call this one. So 1 comes here, right? 1 less than or equal to 1 is true, so this guy is true, because of that it will return 1, right? So that's basically hitting the base case. So the result here is 1, right? So because this is 1, here we have 4, 1 into 4 is 4, so this whole thing will result in 4, right? So 1 into 4 is 4. So instead of this we will say it is 4, right? 4 into 7 is 28. So this guy is basically equivalent to 4 into 7, which is 28, right? So 28 will return here as the result. So the result for this one is 28, right? So it's answer A. All right, we'll move on to question number 4. Okay, so the question number 4, what is the output of the following Java code? Again we are going to dry run this. So that's a recursive function here, right? And then the function is being called here as well. So this is the base case. It's the base case, right? Okay, so where we start the program is the main method, so call func6. So we'll execute this func6, right? So instead of this 6 here, we will say this is 6. 6 less than equal to 1 is false, so it will come here, right? So again we are calling func n minus 2. So this one, so basically now this will be the result is equal to func n minus 2, which is 6 minus 2 is 4, into n, which is 6, right? So we have to call this function again, this function, right? So that's what I'm going to do here again. So we call the this func with values 4, right? So 4 less than or equal to 1 is false. Again it will come here. Again it will be calling recursive function func n minus 2, which is 4 minus 2 is 2 into 4, right? Again we have another recursive call. We have another recursive call here. Again you call this function with 2. 2 less than or equal to 1 is false. Come here. Result is equal to func 2 minus 2 is 0 and into 2, right? Again this should be called. So instead of 2 we call it with 0. N is now 0. 0 less than or equal to 1 is true. So this is true, and because of that it will return 1. So here the result is 1. You get 1 here. So for this you get 1. 1 into 2 is 2. You get 2 here. So 2 into 4 is 8. You get 8 here. 8 into 6 is 48. So the answer you get is 48, right? So that's about it for the quiz. Yeah, we are done with the recursion second section, second activity.